Okay, we're just going to walk through the process of converting ePBR Photosynq or Ideaspec data files into a summary data file using Ideacombiner. So first thing you need to do is put the Ideacombiner executable into a folder, and then in the same folder create a folder called data, just like this, and put all of your Ideaspec files in that folder. And your Ideaspec files should have a certain organization to them that'll look like this, and you'll see that later when we open up the Ideacombiner file to mix them up. In this data folder you should have only two things. You should have your data, which would be all this stuff in this case, and you should have two calibration files. One should be 98 and one should be 99 unless you change that. These are the files that the calibration data gets pulled from, and the current up-to-date calibration files are called calibration 1Z final 98, calibration 1Z final 99, and you can find them on the Ideaspec machine. So put your calibration files in the data folder, put Ideacombiner inside, double click on Ideacombiner, and it'll pop up. Please read it, it has useful information. This is the structure that I was telling you about. So when you save your files, make sure that they're saved like this structure, where these 4 X's are light level, or if you want to change what that variable is, that's fine, but you're going to input it. These 4 Y's are mixing speed, or again, if you want to change the variable, that's fine. Then your file name, and then the stuff that gets added by Ideaspec at the end, where this A is the column depth, which is any number 0 through 7. ZZ is cycle number. Again, you can define that in your program, in the Ideaspec program, if you want. You don't have to. 0 is the column from which time data is pulled, the 0th column in your Ideaspec files. And then these two just are the calibration files that I mentioned earlier. You shouldn't have to change them if you're using standard calibration files. Then, assuming that you're running 2 cultures, two ePBRs at the same time, you're just going to name those 2 cultures. And then this data specifies which column you're pulling the data from. Again, you really shouldn't have to change this. So I have my data in my data file. See, this is what defines the file that your data is located in. See, data. So as long as you call it data, should be fine. These are the output files. It's going to be called main.dat and sum.dat. So we've got our data in there, we've got our calibration files in there, we've got all this stuff defined. And press combine files. And this may take a second. There we go. Now it's done. So we know it's done because it produced these 4 files. They're all CSVs. So if we double click on main.dat, I'm sorry, let's ignore that. If we open main.dat, is just I'll show you. Hang on 1 second. Main.dat is just the summary file, so main.dat contains every single data point from all of the, in our case, 90 files or 88 files located in the data folder. And you can see them all here. So you're never probably going to look at this file, it's just all the data gets pushed into one big file. SumDat takes all that data and summarizes it and generates FO and FM and FS and all that kind of stuff. This FO is actually FS, needs to get changed. And it, it pulls the information out of each of the file names because they're organized in a certain way, which I showed you before. Because they're organized like this, it's able to pull this data into this column, right? All these values, FO and FS and all that stuff, they all have some error correction. So the top two, the two largest and two smallest values are removed, and then there's some other error correction. So if you have some spikes and stuff in the data, it's not a big deal. That stuff gets taken out. The baseline is noted here. It's a separate baseline is measured at each column depth. So the baseline is noted here, and just note that these values are already baseline adjusted. That means they've already had the baseline subtracted. So if you want the original raw values, then take this and add back in the baseline. That's the raw value. Okay. So this is the most useful file that you're going to get. And in order to be able to look at this file quickly and easily, you're going to use pivot tables. So here's what we're going to do to use pivot tables. Just quick add a name to the top of this column. It doesn't matter what it is, just so that the column has a name. And then you're going to select all the columns and all the rows, 177 rows. And you're going to go up to Data and Pivot Table and create current selection. So what this does is it converts all the rows into variables over here. And then you're able to pull those variables to create simple, quickly adjustable tables. So let's say we wanted to know column depth by mixing speed. And we want the culture type, cycle number, and the light level to be constants. And we want the outcome to be phi 2. So we want to see how phi 2 varies based on column depth and mixing speed. And we don't want it to be the sum of all the phi 2s, we want it to be an average of phi 2s. Okay, so we press OK. And there we go. We have this nice table. Here's the column depth. Here's the mixing speed. And then here's our phi 2 values. So what this is saying is at a mixing speed of 25 and a column depth of 2, this is the average phi 2 value for all cultures, all cycle numbers, and all light levels. Now we can say, how about just for culture 1? And how about just, 2000 light level, and how about just the first cycle number? So you can play with these quickly and easily. But let's just do culture 1 at 2000. One other thing to note, you can always edit the layout by right-clicking, hitting Edit Layout. There's a useful thing to do here. If you go to More, you can change this so that you don't total the columns or total the rows at the end here. Press OK. It's a little easier to graph this way. So now we're going to graph this. Whoops. So just select all that stuff, hit Graph, X, Y, and there you go. So you can see, obviously I could add, actually, do first row as label and first column as label. So this is, the column depth on the bottom in centimeters, and each line is the RPM with phi 2 on the y-axis. So that's one dimension of this pivot table. The other dimension we can change by just copying and pasting that graph and changing it to data series and rows. And now we can see it by the other dimension, which is mixing speed on the x-axis, and column depth is each separate line. So you can see how this would be really useful. And of course you can create a bunch of pivot tables. Each time you create a pivot table, you'll just create a new sheet down here for each of your relevant variables for whatever it is that you want to look at. And whenever you change, for example, if I just want to look at culture 1 versus culture 2, it automatically changes these graphs. You will find sometimes that it'll kind of get stuck, so you have to double click on the graph and just change something and come back and hit OK, and it'll adjust. It just gets stuck sometimes, but most of the time when you change this, auto adjusts the graph. So this is an easy way to quickly look through your data. If you want an example of this file and how it's set up, you can go to Google Drive, to the Photosynq folder. Oop. Yeah. And there's a SumDat with pivots example in there, so if you need that. There's also this SOP, and then also the Arduino files and other relevant files will be in that folder as well. So I think that's it. Is there anything else? Missing something? Ideacombiner only works on Linux at the moment, so you need to run this on a Linux machine. The naming convention is important, so make sure to stick with that. I think that's about it.